Hello everyone, I am Tarun Vayam, student of PIT in CSE third semester. Today we are discussing about Sr-Latch. Introduction. What are latches? Latches are digital circuits that store a single bit of information and hold its value until it is updated by a new input signals. They are used in digital system as a temporary storage elements to store a binary information. Latches can be implemented using various digital logic gates such as AND or NOT NAND, and NOR gates. Basically, latches are the building blocks of sequential circuits built using logic gates. Latches digital it store a single bit of information and hold its value until it is updated by a new input signal. It is updated by a new input signal. Okay, they are used in a digital system as a temporary storage elements to store a binary information. It checks the inputs continuous changes output or correspondingly in latches. Okay, these are work with only binary inputs. It cannot be used as a register. Latches cannot be used as a register because register is used to store the information. Okay, latches are can be implemented using various logic gates. We know that there are gates, logic gates, and or not, and NOR gates. Latches are widely used in digital system for various applications including data storage, control circuits, and flip-flop circuits. The latches are various application are the you see that including data storage, control circuit, and flip-flop circuits. They are often used in combination with the digital circuits to implement a sequential circuit such as state machines and memory elements. Sequential circuits, we know that now it is in a sequential logic circuit. Its output is determined by the present values of the input as well as the past values of the output. Okay. Next, characteristics of latches. Latches are basic storage elements that operate with the signal levels rather than the signal transition. Latches are controlled by a clock transition or flip-flops. Latches are level sensitive devices. Latches are useful for the design of the asynchronous sequential circuit. Latches are sequential circuit with two stable states. They are sensitive to the input voltage applied to does not depend upon the clock pulse. Flip-flops that do not use clock pulse as referred to as latch. Study. First point. Latches are basic storage elements to operate with the signal levels. Latches are basically, we know that the basic storage elements to operate with the signal levels. Latches are controlled by a clock transitions or flip-flops. Latches are level sensitive devices. Latches are useful for the design of asynchronous sequential circuit. Means asynchronous sequential circuit, also known as self-timed or rippled clock circuits, are digital circuit that do not use a clock signal to determine the timing of their operation. In asynchronous sequential circuit, there are chances for the asynchronous circuit to enter a wrong state because of the time difference arrival of inputs. In latches, there is a possibilities are there in inputs. There is a difference between the arrivals of inputs. Okay, latches are a sequential circuit with two stable states. Latches are sequential circuit with the two stable states. They are sensitive to with the voltage applied and does not depend upon the clock pulse. We know that in asynchronous sequential it does not depend upon the clock pulse. Flip-flops that do not use a clock pulse as referred to as latch. Okay. Let us move to types of latches. Okay. Types of latches in digital electronics. In digital electronics, different types of latches are there. First one is SR latches. SR latches means set and reset latches. Next one is gated SR latches. It is similar to as SR latches, but it contains gated enable pin. Okay, next one is D latches means data latches. Next one, ga- gated D latches means similar to data latches and it contains enable pin. Next one is JK latches. JK latches means Jack Kilby latches. Next one is T latches means toggle latches. Let us move to SR latch. In this present slide, we know about what is SR latches, how it works. Okay. SR latches, that is set and reset latches, are the simplest form of latches and are implemented using two inputs, a set and reset. The S input sets the output to 1 while the R input reset the output to 0. When the both S and R inputs are at 1, the latch is said to be an undefined state. They are also known as preset and clear states. The SR latch forms the basic building blocks of all other types of flip-flops. SR latches means it is simplest form of latches. It is implemented of two inputs called set and reset. When the S when the S input set it's set the when the S input is 1, it sets the output to as 1. Okay. While R input is 1, it reset the output to 0. When input is 1, it reset to the 0. When S and R inputs are at 1, the latch is said to be an undefined. Whether it cannot be simultaneously, it cannot be have S and R simultaneously cannot be 1. Okay, because it produces undefined or forbidden state. Okay, this SLH is also known as the preset and clear states. The SLH forms the basic building blocks for all the types of flip-flops. Let us move on. SR latch circuit. Okay. In this circuit, circuit is in cross coupled form. SR latch can be implemented using two NAND gates and NOR gates. Okay. When we use NAND gate to implement to SR latch, then the latch is called S bar R bar latch. Okay. Next, when we use NOR gate to implement SR latch, then the latch are called SR latch. The circuit is said to have memory because its output depends not only on the present inputs but also on the past sequence of inputs. Okay, next let us move on to table of the SRH. When set is 0, when reset is 0, it is in previous state and the output is no change. Okay, the complementary of the also no change. When the set is 0, when the reset is 1, the output is in reset state. Because the output is 0, it is in reset state. Okay, the complementary of this output is becomes 1. When the set is 1 and reset is 0, it is in set state. Okay, the output is 1 and the complementary of this output is 0. When the set is 1 and R is 1, it becomes forbidden state or invalid. It simultaneously cannot be become 1. S and R cannot be 1 because it has invalid. We cannot judge the output with what output it comes. Okay, next let's move on. Gated SR latch. A gated SR latch is a SR latch with enable input, which works when enable is 1 and retain the previous state when enable 0. Gated SR latch nothing but a set and reset latch is similar to a set and reset latch which contain the enable pin. Okay, and the enable pin or clock is when enable pin or clock is 1, the whole circuit will be activated and perform the functions. Okay, when the enable pin or clock becomes 0 or input becomes 0, it will be deactivated. It cannot perform any functions. Okay, let us move on to the truth table of the gated SR latch. When the enable pin or clock is 0, then the Q will be in the previous state rather than S set and reset. Okay, when the enable pin is 1, set is 0, reset is 0, it is in previous state. When the enable pin is 1, set is 0 and reset 0, it is in reset state. Okay, when the enable pin is 1 and the set will be 1 and reset will be 0, it is in set state. Okay, next one, enable pin is 1 and S will be 1, R will be 1. It not allowed. It is in forbidden state. It cannot be predict the output of this input. Okay, okay. Let us move on to the application of set and reset latches. First one, data storage. Latches are used in memory circuits to store data bits. Okay, it is used to store the data bits. Say next one, flip-flop construction. They are the foundation for the building more complex memory elements like flip-flops. SR latches is the foundation for building the complex memory elements like a flip-flops. Okay, next one is digital counters. Latches are essential for the creating counters that the track and display the values. First of all, Digital counters. Counter is a device which stores the number of times of a particular event or a process has occurred, often in a relation relationship to a clock. Okay, next. Okay. Let us move on to the advantages of latches. Some of the advantages of the latches are listed below. It is easy to implement. Latches are simple digital circuits that can be easily implemented using basic digital logic gates. Latches can be implemented using basic digital logic gates. Okay. Next one is lower power consumption. Latches consume less power compared to other sequential circuits such as flip-flops. Next one. High speed. Latches can be operated at high speeds, making them suitable for using high-speed digital system. Next one is low cost. Latches are inexpensive to manufacture and they can be used in low-cost digital system. Next one is versatility. Latches can be used for various applications such as data storage, control circuits, and flip-flop circuits. Next. Next, move on to the disadvantages of latches. Some of the disadvantages of latches are listed below. No clock. In latches, do not have a clock signal to synchronize their operations, making their behavior unpredictable. Next one is unstable state. Latches can be sometimes entered into an unstable state when the both inputs yes and set and reset input both inputs are at one. This is also called as race condition. This can be result is unexpected behavior in the digital system. We cannot be predict what output will become. Okay. Next one is complex timing. The timing of the latches can be complex and difficult to specify, making them less suitable for real-time control application. I hope you all understand about this concept. Thanks for watching this video. Press the bell icon button and please subscribe this channel. Like the share and video. Thank you one and all. Thank you once again. ಧನ್ಯವಾದಗಳು ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ.